So I just thought I'd run some more experiments and post them on YouTube. You can see I got my ignition coil, so that's just acting as a Tesla coil type arrangement. Got one wire coming off, splitting into two, going into an AV plug with diodes there. And I've got like 22 LEDs all in series going into these caps here. Now these two caps are 50 volt, 2200 microfarad, and this is just a 300 volt, I think it's 110 microfarad flash capacitor, so it can handle quick charges and quick discharges. And those big ones are basically just like this one, you can see 220 50 volt, and that's just on this battery pack. Got some old really shitty knockoff Chinese crap batteries here. They're about 6 volts, but you can't pull a lot of these, like seriously, these are just crap. It's all off. And I've got my 2 transistors and my virtual ground, so there's no real ground anymore, it's just a virtual ground. So the virtual ground is going into the base of this transistor. Collector is just to a resistance. Now I used to just tap that and get the system started. You don't need to have it on. The emitter to base, and then the emitter to the positive, negative to the battery, and both the collectors are coupled. I've just got these brass standoffs holding them together, and then that's going through the ammeter and then to the positive of the battery. And the capacitor is just there just because I was playing around with residual charges and things like that, but it's not necessary, you don't have to have it on there. You can see I've been playing around with it because the LEDs are still slightly going. They'll charge up to about 56 volts or so, and run those LEDs. Not very bright, but playing around with it, adding the resistance. Obviously, the less resistance, the more amperage, and then the higher this will charge up. The interesting thing is, I'll show you. I just turn it on. You can see there's nothing happening on the ammeter. Can I tap it and turn it on? Yep. So I just tapped it with 1 mega ohm resistance, and you can see it's self-resonating. So it's pulling about 5 milliamps. Let's say 10 for inaccuracies. You can see the LEDs are on. Now if I turn it off, just watch LEDs. See? So the LEDs light, but the capacitors start charging at the same time. It's just that the capacitors take a lot longer to charge than the LEDs. So the AV plug, for some reason, seems to be lighting the LEDs and charging the capacitors, but in a different time frame. So the field or whatnot is still lighting the LEDs, but the time frame to charge these capacitors is a lot longer. Now when I have it in self-resonance, just turn it on by tapping the collector. It's in self-resonance. Once these capacitors charge up to a certain voltage, and they can supply the amperage for these LEDs, this actually shuts off. So it turns off, and then whatever's in the caps runs these LEDs until they run down and turn off. That usually takes quite a few hours. but for now LEDs are lighting. That's pretty much as bright as they're going to get. These caps are charging, and like I said, that will turn off. The self-resonance will turn off once there's enough amperage being supplied back into the LEDs. And there's a few other things that you can do. You can obviously run fluoros off of that, as you can see, if you've seen from my previous videos. You can hook up the resistance permanently to the collector, and the amperage slightly goes up, obviously, but this then won't shut off. So this will just continuously charge up the capacitors to a certain point. The LEDs will continue lighting, and it will stay like that until this resistance gets taken off. And once you take the resistance off, the whole system will then shut off, or you could just manually turn it off. And you can see the capacitors haven't charged much because the LEDs have gone back down in brightness. Now if you disconnect the LEDs, the capacitors will charge faster, and they'll charge to about 100 and something volts. Given that these two are only 50s, I've only charged them to about 100 volts. I didn't want to damage the capacitors, so I don't quite know how much voltage I could get out of that. But the interesting thing is, because the capacitor is still charged with the 6 volts, so you can still plug it in and you get a few more seconds out of the system, and then it shuts off, it drains that capacitor. So that's just something interesting as well. Charge the capacitor back up, turn that off. Alright, so I'll stop this and I'll set up a new arrangement and I'll show you something different. Okay, so something that I did forget to mention, just turning that on, just tap that on, resonance, got that. Now I'm just gonna grab a this is just a, I think 90 volt or 110 volt neon, one of the two. Just by holding one of the legs, you can kind of probe around where the field is. I remember the old cap trats that people used to play around with, so you can see there is voltage on top of these caps, and it's in the field of the LEDs. You can see, like, because of all the metal, so it really likes the metal, all the metal underneath this plastic breadboard. You can see it kind of interacts with that. You can see it's on the one wire here and here, and you can get it really bright if you actually couple with the, see, you can couple with the field there. Come on, get in the hole. Oh wow, okay, so now it doesn't want to. Did I blow? Oh no, it's actually stopped resonating. So I'll just put the resistor permanently on there so that it doesn't cut out. It seems any sort of fluctuations in the system and the whole thing will stop resonating. But there you go, that's bright. But it does go up to like 20 milliamps. So you got your 90 volts or so minimum there. That's basically anywhere you want to go. And it's not shocking me, so that's 90 volts, that's not shocking me. So it's just pure voltage basically that's igniting the filament that's in there. But it's all doing it off one wire, so that's interesting in itself. Okay, so I'll just do another setup, and that's only on that side. It's nowhere on Earth. There is no Earth. Oh, there is. Oh wow. Okay, there was none before. Ah, this is interesting. So again, like in one of my previous videos, wow, so this is showing 90 volts as well. And when I actually load this up, again, the amperage goes down. Now, is it on the collector? Yep, it's on the collector as well. Except if I touch the collector, the amperage goes up. If I touch the base, amperage goes down. Only very slightly though. Yeah, no, just very slightly. There's just a little tingle on the interesting. Goes up. I think it's on the positive here as well. Yeah. So on the positive of this battery, negative, so it's like everywhere. Yeah, it's everywhere. So basically this whole field is encapsulating this whole assembly here. I guess that's why you can get the nice little resonance going. So basically all you do is have a virtual earth on the base, and but it has to be large enough. I've tried a smaller earth and it doesn't quite work, won't get there. I'm sure with a higher voltage you can probably get it. 6 volts so far is as low as I've gotten this thing to resonate. For some reason the noise has gone as well. It used to make a high-pitched noise before, even at low amperages, but now it seems to have gone. So that's something interesting. Turn this off. Okay, so yeah, you can see the capacitors have charged now because they're providing more amperage to the whole system. You can see I've turned it off. And it's off, there's no current draw. And that was slowly discharged, and then you can repeat the process over and over again. Now I don't know how accurate that is at these frequencies and these sorts of voltages. I don't know how really accurate that measurement is there, but these are really shitty batteries and I have been playing with them for quite a while, so yeah, I don't know. I might do like a run test one night where I just leave the resistor on and see how long these batteries will actually run and light those LEDs. I mean, 22 LEDs are pretty bright, so they're probably pulling a milliamp, 2 milliamps, something like that. I think 5 milliamps to 10 milliamps is them at full brightness at 3.6 volts or so, but they're probably only getting about 2.2 volts and about what, a milliamp or so. But so yeah, not a lot, but 22 of them combined, you know, as a night light or something, that could be interesting. Okay, onto something there. Okay, so here we've got pretty much the exact same setup as before. The only thing I've done is I've gotten one of these voltage quadruplers, or whatever they call it, radiant captures devices. Yeah, people call them all sorts of different things. There's a few different schematics on there. So this is where you would plug in your earth on this red wire, and this is where your antenna would go. And the antenna is obviously, I've got this metal sheet of aluminium, and all I've got it right now is just, I've got my LEDs. You can see they're plastic underneath, there's no connection, and I've got my reader here, and you can see it basically tells me if there's a short. Everybody knows how these work. But what I did is I sprayed this board, mainly because these work really well, these radiant captured circuits, if you have this, what do they call it, isolated basically. So I just sprayed it with varnish, so it's completely isolated, there is no connection. You can see that there's a thick layer of varnish on this, so there is no connection at all, and it's completely isolated. I mean, if I dig it in there, I'm sure I'll break the connection, but so yeah, you can see that it's not connected. Got my voltmeter here connected to the positive and negative, where you normally would have your positive and negative. And you can see, I'll turn on the system. I've got my now self-run. There you go. That's charging the capacitors and passively also charging the little circuit here. And I haven't really tested what voltage. Now those are two 300 volt flash caps, and those are just I think 1 kilovolt, like 1.1 or whatnot microfarad caps, something like that, germanium diodes or whatnot. Just a voltage quadrupler or whatever they call them. Like I said, so it's not connected to earth, it's just basically collecting the radiant straight off that plate, isolated. And if you lift the LEDs off, you can see the whole circuit turns off. Let me just start it back up. Now I'll keep the resistance on there so that it stays on. You can see it's 10 milliamps now. I'll lift up the LEDs. Get them down to a certain stage. There you go, now it's coupling. You can see. So, like, yeah. This reminds me of like the Don Smith device or whatnot, when he had capacitors between sheets of glass and things like that. There is slightly an extra draw, but that's because of this capacitor, this resistor. If I take the resistor off, it goes back down to the 10 milliamps or whatnot, but it continues charging this. So we're up to 13 volts now, just running that. And I've checked, those capacitors seem to charge at the same rate, LEDs and everything. Now what I haven't checked yet is whether this will stop resonating once those capacitors charge up. Now usually it should, but because it has that plate underneath now, it may keep going until these capacitors actually charge up. I don't know. But you can see, I have tried putting the earth wire that you usually connect this to this virtual earth. It doesn't seem to do much. So it purely, this side of the circuit, you can see that side of the circuit purely likes to run in high resistance, high resonance with just off that one wire. You try to couple it with anything or loop it or anything like that, and it will just shut off. It won't work. I've tried looping all this stuff back to the capacitor and all this and that. It won't work. It doesn't work. It doesn't like it. Like everybody keeps talking about, the two energies just don't like each other. You can turn one energy into the other energy and that energy back into that, but you can't couple them. You need a third system in between, probably converting the whole thing and switching the whole thing for this to run, for it to self-run basically, if you want to try and attempt that. I'm just purely studying it at the moment. I haven't really seen anything like this yet anywhere, so just thought I'd share. I haven't tried putting a neon across that. I'm sure, hey, 22 volts. It will still run. Actually, let's try that. Let's turn it off. You can see it stops charging. That would go down because these capacitors are very shitty. And okay, I'll put a neon there and let's have a look in a minute. Okay, so now I've got the neon, and again remember this is isolated, so it's not going to short out or anything like that. Off the one wire neon, I can't get it to self-resonate. I need the resistor on there. So I've got the resistor, it's pulling about 10 milliamps again. You see the neon's just very brightly on, and this piece of aluminium is just really ringing now. So you can see how the high voltage moves air around as well, and it's the jitter effect of the whole system, thing like Bearden talks about. But yeah, it still charges. You can see it charges up, and you can see I've got that turned off. So this is just running off the caps, these LEDs, of what was charged there. It does seem to charge slightly faster each time. I don't know, maybe not, because you can't have these meters on them while it's running. The whole system will just stop. As soon as I try to put a meter on here, the whole system, especially in self-resonance, I have to keep this capacitor, this resistor on there. But the resistor then increases my voltage, my amperage. I don't want to do that, obviously. I want to run it as low amperage as possible, so that I can maybe later on run that with those crystal batteries and things like that. But yeah, not a lot of light, basically none. The camera's showing a little bit of light, but I can barely see anything. But at least the high voltage is there. It's still charging that. If I disconnect it, there you go. If I just decoupled it and really ran it off one wire, now I've got a bit brighter. The amperage is still the same, maybe slightly higher. It's brighter. It's still charging those caps. So yeah, that's pretty good. Alright, I'm going to put a large fluoro on there now. Okay, so my battery's going dead, so I'll have to make this quick. So I've got the large fluoro on there now, that 36 watt fluoro. Wants to self-resonate again, so I'll just put the resistance on. About 10 milliamps, a little bit of light, and still charges that. Running off the one wire. Now what I'll do is I've got this large virtual earth here. I'll put that there. Let's see if this does anything. Nope, that does diddly squat. I wonder if it's going to shock me. Nope, no shock. Okay, well that's good. I'm surprised that this runs, because an observation I had before is when this large fluoro is on the same ground level as everything else, you used to pull it like 100 milliamps. But that was of 12 volts. This is only 6 volts. Of 12 volts, that was really bright. Pulling over 20 milliamps. It went off the scale of that amp meter. So what I had to do was elevate it. So I had a chair and it sit about here, about half a meter above the whole setup, and then it would only pull about 40 milliamps. So I thought that was strange. But another observation, you can see it's still charging. Another observation was that the system seems to pull less and less the longer it runs. Like you can shut it off, and because I've been playing around with the system so long, after you shut it off, you then turn it back on, and it pulls a little bit less each time. Because I mean, at the beginning, all this, exactly the same setup, it was pulling about 40 milliamps. And then the more I played with it, the less it would draw. And I've tried moving this around. Like I did have it in this spot here. You can see I was hooking it up to real earth and doing all sorts of things. But just for this video, I moved it here just to make sure that it wasn't localizing to this area here. Now it's fairly close, so it might still be localized, but yeah. Wish I could build a Faraday cage and test it all out in a Faraday cage, but I don't have one. And I'm not going to build one just for this. This is just fun. I think that's what everybody's really... It's interesting stuff. I mean, holy crap. Running LEDs and fluoro. Okay, sorry about that. The battery did die. So I just have my phone on charge. Hopefully it's charged up enough and I've deleted and yeah, hopefully it will last enough to finish off this. Okay, let me just disconnect it. Okay, so as you can see, there's no tricks here. Got no hidden wires, no nothing. Those who've played around with this will know that this isn't a trick. They know how this works. All those people who don't know how this works, well then go and do some study. So what I've got is basically I've gone back to the same setup. Got my LEDs. You can see they're almost dead. And to this here, I've plugged in a 10 watt, 32 volt LED. It's a high powered LED. And I love these things because when you run them off this cold electricity, I've had this thing to full brightness, almost 80% of what 10 watts would really look like. I've got a flux meter, so I was able to make sure that I had the same amount of light coming out. And yeah, no heatsink required. This thing just runs cold. So almost full 10 watts running through that LED of cold electricity, and it runs cold. I mean, duh, that's why it's called cold electricity. So no heatsink required. That was awesome. But in this case, I'm just going to charge this up using this method of that plate there. You can see it's really dropped down. This meter, I think, is eating all the freaking potential of that. So everything's the same. Let me just turn it on. I'll have it off the resistor so that it doesn't turn off on me. You can see LEDs instantly turn on. Just to show the interesting part, it charges the capacitors at a different time scale than running the LEDs. Normally the capacitors will just consume all the charge until they got charged up to the level of the LEDs and the LEDs would run. But in this case, nope. See? And that residual going down is obviously that capacitor. So you can see, had it on, they've gone back down to almost not on at all. Turn it back on, they instantly turn on, and the capacitor charges. Now I might put my meter on there in a minute just to show you. But I mean, that alone demonstrates that it's working. And we're pulling about 10 milliamps. And this is charging. So once we get to about 30 volts, this LED should start lighting. Let me just check that I've got the polarity right. Positive, negative, negative, positive. Yep, so that's correct. Now I'm assuming that having the meter on here is going to interfere with this charging slightly, but just to show it off, I figured I'd have it on there. Okay. Yeah, this is pretty simple. Now, yeah, the fact that this is in a spiral or something like that, this is just copper tubing. I like the fact that when you touch it, it goes up, couples to me. And you saw the neon before, there's actually a high voltage here, but it's not shocking me, so that's fine. And it does speed this up, obviously. Yeah, you can see, and you can hear the resonance of the foil. But 18 volts. Nope, still nothing. No, 18.4. Okay, so now it's really slow. Okay, I'm just touching it to speed it up. You can see 20 milliamps, and I'm touching it, touching the earth. so it's earthing with me. It's really going to take a while, isn't it? I know what I'll do. I'll just lower the resistance. Oh, bugger. Alright, I'm going to stop the video so I can lower the resistance, because I can't do it with one hand. Okay, so I've lowered the resistance. We are on 150k. We're pulling 40 milliamps with 6 volts. You can really hear that ringing now, but at least this is still charging, sort of. Now I wonder if it is really the meter. Now at this sort of pull, I'm sort of dreading touching this, but no, it's all good. Whew, it's good. Yeah, now it starts sort of. Okay, so that's a failed experiment. That's not going to charge up high enough to pull this LED. Though I have had this up to like 50 volts before. Ah, that's right, that was without the meter. So the meter's really eating up this frickin' voltage, the bastard. It's a cheap Chinese frickin' fluke knockoff, so it's not the best meter in the world. Yeah, no, that's not going to do anything. Okay, let's just take the meter off of it. And I guess while we're waiting to see if that will light, we can check the voltage on here. And even with the supply voltage, putting a meter on it really interferes with the whole setup. But because we have this resistance to keep the coupling alive, it seems that it's going to be fine. Oops, hooked it up wrong, but you can see it. So it's 5.26 volts. And for shitty batteries, they're holding up pretty well. But then again, they're only supplying 40 milliamps, so it's no surprise. Nothing screaming its head off. But still no light. Oh well. Oh well, I'm not gonna waste your time trying to get that to run. So yeah, that's it so far. I think that's all my observations and tests that I've done. Just thought I'd let everybody know. Oh, and yeah, if you've watched so far and all the way to the end, thanks, and thanks to all the subscribers. Yeah, I think I've got like 50 plus subscribers now. That's pretty interesting. And a few of the people that I've admired and I've been watching on YouTube as well and following their work, they've subscribed to my channel as well. So really appreciate that, guys. Thank you. I'm not going to monetize my channel or anything. I'm not a sellout. I don't do that shit. So YouTube can kiss my ass. Whoops, sorry. Nah, still not lighting. But yeah, at 40 milliamps, these batteries are going to drop really quick. Like I said, they're really shit batteries. But okay, well yeah. Thought I'd give you an overview. That's the whole setup there. Not hard to follow, and nothing new again. Just the experiments seem to be slightly different than what I've seen around. Okay, again, thanks for watching. See you later, guys. Happy experimenting.